Welcome to this session in the Cloud Lunch and Learn Marathon series. This is 10 cloudy questions to ask before migrating your SQL Server. My name is David Klee. I am the founder of both Heraflux Technologies and Sequilibrium Education. I'm lucky enough to be a Microsoft Data Platform MVP and a VMware V expert, and I have a whole lot of fun doing consulting and education around how infrastructure and database technologies work together and a lot of times just don't play well together. Okay, we are going to talk about what actually is involved with migrating your SQL servers to one of the public cloud providers and doing this in a way that actually works best for the given data that you've got. So, we're going to start by laying some ground rules here. First of all, just what is the cloud? I know this is a loaded topic, and if you ask 10 IT people just what is the cloud, you're going to get 22 different answers. So, I'm going to give you my definition of it. First of all, there is no cloud. It really is just somebody else's data center with really good virtualization and even better automation. That's functionally all it is. What it actually does, though, is it allows the power of the automation and the virtual platform for movement and somebody else's data center for capacity and uptime and availability to give you the ability to self service and leverage this platform as you see fit. It means we have the ability to log into a portal, provision a VM or a database as a service or a load balancer or a website and spin it up and manage it ourselves. Their automation takes care of all the dirty work, but we don't have to. We can just start to use it. Given the power of the web platforms, it's not just virtual machines and servers out there. The automation capabilities of these platforms give you the ability to turn around and leverage things as a service. For example, an Azure SQL database means I get a database that's there. It works. I can use it. I don't have to worry about patching. I don't have to worry about operating system updates. I can literally just use a database. Their automation takes care of the rest. Now, I don't get access to the underlying operating system, but that's okay. In these particular use cases, if that's the right path for the data you're going with, if that's the right service, well, I don't need it. I just straight up don't. Okay, a few definitions here. First of all, infrastructure as a service, or IaaS, is essentially nothing more than virtual machines. In this case, we're going to install a copy of SQL Server in there. It's basically business as usual. Platform as a service, or PaaS, this means I use something like an Azure SQL managed instance or an Amazon RDS for SQL Server environment. I get the full power of SQL Server, but I don't have to deal with an underlying operating system. And we all know how many times we've been up in the middle of the night having to patch this stuff. Maybe I just need a database, literally a simple database, no problem. They have that out there. We can go provision this database as a service or DBaaS because we love something as a service, right? All the buzzword bingo. From my perspective, I know this is an Azure marathon. I might as well just mention the other ones. Microsoft Azure is the big one that we're focusing in on here. There's Amazon Web Services, there's Google Cloud Platform, there's Alibaba Cloud. To me, I stick with Microsoft Azure. And it's not because I'm an MVP or get credits or anything like that. It's quite literally they own the code. They wrote Windows, they wrote SQL Server. I get all the bleeding edge bells and whistles a whole lot sooner than I do in the other environments. And I like that. I like to be able to take advantage of the newer features out there to help solve business challenges. Now, where is the cloud? Well, it's on land. It's not in the cloud, even though it'd be kind of cool. The map that you see on the screen here is available out at azure.microsoft.com. They're constantly updating it as they add zones and regions in there. You can see there are data centers worldwide that really go a long way to letting us put our compute where we need it. This might be closer to you and your headquarters. It might be closer to where the bulk of your customers are. Or maybe I have a decentralized service and I can spread it around and get it closer to all of my customers. It's up to you. It's up to how your country laws are mandating if data stays in a certain location or not. It's up to your business needs, but you have a lot of choice, and that is fantastic. Okay, question number one. Why are you considering moving to the cloud? And I know that the folks watching this, they may be well involved with the cloud journey. They might just be treading the waters. They might even just say, hey, no way, but I'm curious what he has to say. To me, all of those are acceptable answers. I want cloud when it's the right tool in the use case. So a lot of organizations out there, now cloud, drop everything. We got to go. We got to go all in right now. Move, move, move. Go get there. Well, it's not necessarily that easy. If you have an organization that's saying we're going to the cloud right now because we read it in a Sky Mall magazine or something, I'm sorry. You have to have a legitimate business reason in order to go to the cloud. And there are many of them. But just because all the cool kids are doing it might not necessarily be the reason that works for you and your organization. Why move to the cloud? And I joke about a CEO reading it in a trade magazine, but I've heard multiple occurrences where very large organizations are saying, we're going to the cloud because he read it in a trade mag and that's what we're doing. And that's not always a good, legitimate reason. We have to compare and contrast. Why do we need to move to the cloud? What business strategic advantage does going to the cloud actually give us? There's public cloud, but there's more options than that. There could be a regional colo that you may already have an established relationship with where, they're down the road and if there's a problem, you can run down there and yell at them and they'll take care of it. There may be cloud services where you want to leverage a piece of the cloud. It's not necessarily all in. The automation is what makes this. This to me is where some of the cloud services and the public cloud models really shine over some of the regional stuff or some of the do-it-yourself options. One of the bigger questions that I want you to ask up front is what competitive advantage does going to the cloud actually give us as a business? Not just a technical achievement or a checkbox, but what does it actually do for your business? You have to be able to quantify this because if you don't, when you start to run the numbers, it may not necessarily line up. And that's a real challenge, not just from a CIO perspective, but a CFO or a CEO. And then, if possible, quantify the advantages in a way that allows you to monetize this. It could be greater uptime means more revenue for an e-commerce store, or your business is now more highly available in the event of a disaster. These things happen, and it really does matter. This is not just a technology change. It does not mean cloud is an IT driven push. These are organizational choices. The business must be aligned with this because there are a lot of things that are different with the cloud. That's not necessarily to say good or bad, but it's different. If you want to play by some of the cloud rules, you may have to change how certain things are managed and operated, which usually is for the better, to be honest. But you got to be on board with this. Otherwise, you end up with a really unhappy customer base. And what do you get out of that? You get a lot of uneasiness in the organization, and that's never fun to work in. A lot of people look at the cloud as an end state. Not necessarily, I don't look at it that way. I look at it as a means. It's literally a platform. I need to use it to modernize and streamline and make things more efficient and potentially save cost, but it's not an end goal. The cloud is constantly changing. Your processes need to constantly change to keep up with how to most advantageously use the cloud. It's not the end state. How do you measure the value of what you're getting out of the cloud? And this could be cost savings in terms of staff time to manage routine operations. It could be we're able to scale up now in a way that we couldn't before for certain big, things like the United States Black Friday, the day after Thanksgiving, things like that. How can we measure this stuff? Or just like we all have, if you have skeletons in the closet with your data platform, legacy application designs, processes that are manual that you know you can automate, but you haven't had a good automation platform to do this. Now is a really good time to revisit all of these things that you think can be modernized and start to leverage some of these features in the cloud. Now, you may be able to orchestrate it through the cloud and run it on prem. It may end up in the cloud. We don't know. But now is the time to start really revisiting what can we do better by going to the cloud? Can we save time? Can we save money? Can we simplify it? Can we make it more highly available or more scalable? These things matter. There are a lot of myths around going to the cloud, and I hear a lot of excuses and a lot of bad things that people hear or good things that are completely false. So let's address a couple of those. Lots of people think that moving to the cloud is an all in, you're going to eliminate all these jobs and get everything completely out of your data center. And I'm sorry, but it's not. You can go hybrid. You can selectively use things in the cloud that make the most sense and keep the rest on prem. A lot of people think the cloud is cheaper. This is a really tough one to quantify. If you look at the operational costs of a major cloud provider in terms of literally just what you spent on compute, storage, networking, licensing, and the application, the database layer itself, and you compare that to what's out on the cloud is not cheaper. But when you start to look at how much staff time do you actually need to maintain the physical platform, Or what are you doing right now that is manual that the cloud allows you to automate? Or what cloud features and technologies can we adapt existing processes to that may be able to streamline and save money? At that point, the cloud might actually be more cost effective. And a lot of times I find that cloud usually isn't cheaper, but it's usually not much more expensive than what you get on prem. And the fact that you don't have to maintain that data center, especially if something acts up or something fails, that amount of reduction in staff time alone will help you get to where it's definitely less it's less of a gap than you would think. My personal favorite, it's better. I love subjectivity with this stuff. Cloud is different. Cloud is definitely not necessarily better. It is different. There are improvements in a lot of things. There are changes that may actually cause regressions in others. It may not be more expensive, but it probably isn't cheaper. There are areas where it just changes. So when a lot of people look at the cloud as this paradise, I'm sorry, it's different. There's a lot of positive things about the cloud. It may not necessarily be better. And then my other favorite, no maintenance is required. No, you still have to maintain this stuff. There are certain pieces of the cloud that you don't have to worry about, such as if a disk were to fail in a storage device. Well, they've got automation and resiliency baked into it. They're going to take care of that. But application level maintenance, if you're running virtual machines in the cloud, you still got to patch it. All these things, you still have to maintain it. The maintenance may be less, the maintenance may be different, but you still got to worry about it. And then it's easy. No, cloud is not easy. Cloud is different. And depending on how you use it, certain pieces of it might be easier to maintain and manage, but it's definitely not easy. And then it makes things faster. Well, I'm sorry, but a lot of times, if you're coming from a brand new state of the art environment on prem where you've spent tons of capital to go buy the fastest CPUs and the fastest storage, I'm sorry to tell you, cloud may not be quicker. It might actually be slower. Alternatively, if you're coming from a 12-year-old data platform and you're looking to literally lift and shift and get out to the cloud right now because your equipment is literally cranky and about to die, yeah, it's probably going to be faster. It really all depends on what you're coming from and where your bottlenecks are at. A lot of times we may be able to throw hardware at it on prem. In the cloud, you're throwing money at it. It may not necessarily be the right approach. And then people think stuff in the cloud is just guaranteed to work 24/7. Well, just do a little bit of search engine searching and you're going to find reports of cloud outages all over the place. It goes down. Pieces of it go down. Pieces of it can run degraded. It happens just like in your own on prem environment. So just set the expectations and understand the service level agreements of any of the services you buy into. They're published, they're well broadcast across any of these platforms. You just have to make sure that the expectations are set within your organization to be able to really leverage and deal with that if there are outages. And then everyone's doing it. Well, a lot of people are looking at the cloud. A lot of people are electing to use certain pieces of the cloud. Not everybody is all in. Not everybody's even thinking about it. A lot of people are, but not everybody. Okay, we had a lot of myths there. Now we have a lot of facts. Cloud is extremely flexible, and that's one thing I absolutely love. If you can dream it, chances are there's a cloud service in there to where you can adapt, shift, tweak, leverage something. You have all the flexibility because you have the automation at your fingertips. They've done the hard part by making all that stuff work. You just start to use it. Cloud and security. This, I could go on for hours on this one. I would argue that your on premises security practices are poor. I say this carefully, but I've seen a number of different environments out there. And usually on prem, things are wide open and then they're locked down selectively to either try to lock things down for a certain environment or pass a security audit, things like that. In the cloud, they are so locked down that you can't even get to it when you deploy it unless you start poking holes in their firewalls. I think that's a good thing. I think that we can now look at the exclusions on any of the cloud services and we have a much better idea of how they're actually secured. You've got data protection baked into a lot of these things. There's compliance where you can actually buy into healthcare, government, regulatory compliance required cloud segments. And you have the ability to do audits and really certify that these things are secure a whole lot easier than you did on prem. And I mentioned it before, but the opportunity to modernize your application stack and your database layers really are significant in the cloud. For example, if you're on-prem and you've got a failover cluster, maybe I want to go to an Azure SQL managed instance and take advantage of essentially an availability group or a much more highly available environment that's got a lot tighter SLAs. Okay, I said it before, but the automation capabilities of the cloud are fantastic. And because of that, we can now leverage the cloud to use the platform really at the speed of business to perform IT operations. If you needed to stand up new equipment on-prem, you'd have to go wire it, rack it, stack it, burn it in. Hopefully you get it in time with all the shortages lately. They've got the capacity. They've got the automation. So you go to a portal, you click through a little wizard, get out your credit card, and out pops what you need, and then you can start using it very quickly, usually within minutes. Scalability is another one. They have more hardware than you do, period. They can scale up as big as you need. There are not that many workloads that I would say are not suitable for the cloud at this point because you can scale really through the roof with what the cloud can do. Usually you can scale so high you couldn't even come that close on-prem at all, even with a really big budget. And then I've said it before, but that automation, it just continues to amaze me, just what you can do through their control portals. And then if you use the cloud really at all to manage a lot of these things, you're going to make your staff time more efficient so they can become more proactive with these key systems and the routine operations and management. And you can start to help them truly become more proactive to help you better use those platforms to support the business operations. And then the biggest one for me, and I'll talk more about this in a little bit, is the financial model shift. This is a big change for organizations out there. It is a shift from a periodic capital expenditure to an ongoing operational model. And what that means is in the cloud, you're billing up front. On-prem, you might do a big purchase every 5 or 6 years for an application infrastructure stack component. Well, now it's shift to an ongoing model. It's a big change. It may be something that your organization is really happy with. Other organizations, they say not so much. We actually like the upfront purchase. And then the thing I always come back to, as a business, small or large, are you in the data center business? You're not a hosting provider. You're going to have trained professionals on staff to manage each of these components and monitoring and 24/7 operation management and capacity details and backups and redundancy and all this stuff. Are you in the data center business? Probably not. And if you're not, does it make sense to maintain your own data center at this point in time? And I can't answer that for you. It just might. But then again, it might not. Okay, question two. How do you want to use the cloud? And this is a big question because not all these services are used exactly the same way. Like I mentioned a minute ago, cloud is not necessarily all in. You can selectively use the pieces that complement your needs. It's kind of like you got a toolbox now with 150,000 tools in it. What's the right tool for the job? We have to understand the offerings because we have to understand what is available to us and then understand our use cases to figure out which of these platforms and components that we actually need to go leverage. Because you need to understand the offerings, now we have to define the strategy before your migrations begin because some of the migration strategies are different. The way you leverage certain components could be a little bit different. And we have to figure out all the pieces around how do we want to best leverage this thing. And it might mean some modernization, it might mean a lift and shift depending on what we're coming from, but it changes. So what some organizations are doing, they're just now starting to test the waters. And me personally, offsite storage for backups is a fantastic way to actually get involved with the cloud. You can start small. Literally use the cloud as offsite storage to replicate your backups to. You can do this by replicating your virtual machines, your database backups, letting it sit out there for some indefinite period of time that matters to the business, clean it up when it's done. And it's a real good way to get started with it. Using the cloud for either hot, warm, or cold standby something as a service, or even replicating storage out there, that's a whole lot cheaper than do-it-yourself disaster recovery. We have a number of organizations out there who, no exaggeration, they will spend tens or hundreds of thousands of dollars or even more to go stand up a whole bunch of equipment in a DR facility, go through all the pain and the exercise of going and failing over and testing it, making sure everything works, maintaining, managing it. And 99.99% of its life, it's literally a space heater. That's a lot of money for something that's just sitting there. If we can leverage the cloud, maybe we don't need to provision as big of machines out there or deal with cool archival tiers. So it's there and we can recover from it quickly. Now, I've mentioned it a few times now, cloud will move faster than your organization's IT department. That is virtually a guarantee with the kind of environments that I've seen out there. In the cloud, we can provision stuff in mere minutes, in just a handful of seconds to either click or script through whatever we need to go do. If you're on-prem, usually you think they have automation, you put in a request for it. Most of the time, it's literally some person on the other end of the screen running and manually building all this stuff and then handing it over when they're done. That's not very cool. The cloud also gives you the ability to scale outwards with the right application architecture. And that gets really interesting because if we have web application servers, maybe we have some data platforms where we can use something like a hyperscale database out there or elastic clusters. We can scale this thing to as big as you need. And you can scale out appropriately if the data architecture and the platform are set up right. Or maybe there's things like scaling to the cloud when needed and scaling back when you're done. Many years ago, I worked at a performing arts center, and we would occasionally, 2, 3 times a year, we'd get a really big show that would just nail the systems really hard when things went on sale. If the cloud had been what it is now back then, we would have been standing up web servers and the big database server out there and scaled up a lot of different web app servers to handle the load. And as soon as that on sale was done, we'd scale it right back down. Just use that burst capability of the cloud specifically to help your organization scale when needed. If you do this on-prem, I'm sorry, but you're buying tons of equipment for 1 or 2 times a year that you actually need it. Now, if you want to go tread the water a little bit more deep, you can start to use specific services out there. For example, all the integration components, there's data lakes, there's reporting, BI, analytics, machine learning tools. These things are fantastic. You can start to scale out your data with something like Microsoft Cosmos DB, and we use this for Perfmon collection all the time, and it's awesome. Or maybe your organization truly is just done with being a data center provider and it's time to go all in and literally you want to move everything and get it out there because you're just done. We've got one organization right now. Their primary data center is in the basement of this building. It's an old building, and the water main for the building comes in and runs directly over their row servers. The new CIO came in, saw this, and said, nope, it's going to cost too much to move that water main, too big of a risk. We're going to the cloud just so we don't have to deal with that. So now, if you're all in, what do you need to do in order to move everything? And there's a lot to think about. How will your users connect and interact with this thing? What about the applications? And this is where stuff gets kind of tough. So if you're all in, but maybe you want to keep stuff on-prem but leverage cloud automation. And I really don't want to sound like a marketing pitch here, but Azure Arc is something I've been watching and tinkering with, and it is really slick. I want the cloud automation and provisioning capabilities and all that automation, but I just want to do it in my own data center. Or maybe I want to have part of it in my data center and part of it in Azure, and maybe actually leverage multi-cloud workloads, maybe in AWS. It's incredibly powerful stuff. It's up and coming. They're coming out with new pieces all the time for it. If you're interested, go check it out there at azure.microsoft.com, blah, 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 Azure Arc. It is really cool. I've been watching this. And for all the folks that are out there with a significant data center presence on-prem, maybe you're not ready to retire that yet, but you want that power that's in the cloud. So you can actually wire in your on-prem data center with Azure Arc and have a single control plane, single bit of telemetry, single management interface. It is incredibly awesome. Now that we know how we want to use the cloud, there's a lot of cloud database services out there. So what cloud database services do you need for a given workload? Do you just need a simple database? Or maybe we got a couple of databases that talk to each other, so we need a single instance. Or maybe all the features, all the management, and all the pain that comes along with dealing with an operating system. It's up to you. It's up to your workload. It's up to the application architecture. So we're going to start small. Let's start at database as a service. So on the Microsoft Azure platform, I'm talking about Azure SQL Database. And it's literally a database. There's no agent, there's no mail, there's no integration services, there's none of that stuff with the core database, but that's okay. If I just need a database, it works great. There's no OS. I don't have an instance to deal with. It's literally just the operating system. You're going to see this theme a lot here. The availability of this depends on what criticality tier you go select. So you can do general purpose, you can do business critical. Disaster recovery, you basically click on a map, pick a different point on the map, get out your credit card, call it good. Now, maybe I've got databases that talk to each other, like underneath Microsoft SharePoint or a number of other application database designs out there. It matters. These things will not work in our Azure SQL database. So maybe we need a managed instance, and Amazon's got RDS for SQL Server out there that does similar stuff. It is a SQL Server instance as a service. So you can have a ton of different databases out there. You get the agent. You don't have operating system access. And quite frankly, I've said it before, I'm fine with that. I'm tired of patching this stuff in the middle of the night. Let their automation take care of it. I don't care anymore. I just need to figure out what availability do I need? What disaster recovery options do I need? And then pick some criticality tiers. And again, standard general purpose and business critical. If that's not good enough, go take a look at some options for getting that data in multiple places. But it works and it's really solid. What if I need the full power of an operating system? Maybe I've got some legacy practices. Maybe something is just weird and funky, or I just need that layer of interaction. So it's pretty simple. Put SQL Server in a virtual machine out there for IaaS. You have full control. Basically, it's business as usual at this point. The only trade offs, you patch it, you make it highly available. Cloud DR, though, is easier. Essentially, if you need to replicate this thing, you can pick an additional site. You can replicate through any of the backup mechanisms they have out there. You can actually back up your databases to Azure Blob. There's just a lot of flexibility to get with it if you need it. Me, I'm tired of patching the operating system. So let's just let them worry about that. Now, if you want to replicate your backups from a lot of these things, you can actually back up to URL. And yes, that is valid syntax right there. I can back up a database to a given URL with a credential that's stored, and now I have my backups in a decentralized location that are going to be redundant. They're going to just work, and you can grab them from anywhere. You can copy, do full backups, differential transaction logs, and just get it out to Azure Blob. If you do this, don't forget about your system databases if you were managing the virtual machine itself. If it's one of the managed instances or SQL database, you don't have to worry about it. But if you're dealing with all this, you got to worry about getting all these other pieces in there, just like we normally would if it was on-prem. Question number 4, what are your availability requirements? And this is a big one. So I'm going to tell you, skip the technology. You go straight to your C level. There are 2 things that you have to define in order to properly design this environment to be highly available in disaster recovery. 1, there's a recovery point objective, or RPO. Essentially, how much data can you lose? And then there's a recovery time objective, or RTO. How long can this thing be down? I'm not exaggerating when this was a real world scenario that I saw. The C level had declared that your recovery point objective be 15 minutes and your recovery time objective 1 hour. What that means is they were not willing to lose more than 15 minutes of data in any situation, and everything had to be back up within an hour. The data folks never got the memo on this. So they had a defined SLA in their organization that says we have an RPO of 30 minutes. As a DBA, they were backing up every 30 minutes, but they didn't want it to collide with any of the stuff that normally people always schedule on the hour. So they were running them every 15 on the 15 and 45 of the hour. No problem. Okay, so here's time. Here's 12:45. We got a transaction log backup. Life is good. 1:12 p.m. SAN failure. Massive problem. They had more than one SAN there, thankfully, but they had to deal with a virtual machine restore and then a database restore to get this thing onto this other storage device and back up and running, and that takes a little bit of time. 3:55 p.m., they are finally back up. We now have almost 30 minutes of observed data loss, and your recovery window from it is basically the time that the thing went down to the time it comes back up. Your recovery goals, 15-minute RPO, 1-hour RTO. Well, you just breached your SLAs. I'm sorry to say that in some organizations, that is a resume generating event, which is a real challenge. What you need to do is you need to go to your C level and say, skip the tech. Tell me, for planned and unplanned outages, what's my recovery point and recovery time objectives at the same data center? And then from a disaster recovery perspective, what's the RPO and the RTO? And let them define it. Stay out of their way, let them define it. And I'm not kidding. Make them print it and sign it. Those are the guarantees that you are going to be engineering this environment to meet or exceed. If their expectations are different, or when you start putting the numbers together to define the architecture and get to what they're asking for, if the budget just isn't there, you go back to them and you say, look, we can't do it in the budget you declared because we don't have this or that. So either you need to reduce your expectations or you need to give me more budget so that I can do what you've defined here. And that is a really big deal. Once they have defined the SLAs, now you can turn around and pick the service tier of whatever cloud service that you're looking at. So on an Azure SQL database, I have general purpose. I also have business critical here. All of the cloud platforms with every data platform have multiple tiers and they have SLAs defined in there. You need to be really careful with this because X number of nines may not necessarily mean they're only down for a couple seconds at a time. They may be able to have, minutes or hours of an outage. And well, you need to look into what is your recourse if that exceeds some of the SLAs that you've defined with the service tier. So again, you can see general purpose, business critical. Make sure they understand the difference on here because the organizations do matter. These SLAs do matter. And if you want to pay a little bit more, you can go up to a business critical tier and you will get better availability. If the targets that the C-level have set exceed what options you have on the platform, re-review the platform selection. There may be some options that you can do there, or you may be able to complement the platform's high availability options with your own. For example, let's say I need a virtual machine, but I still need good high availability. So maybe I can go build a SQL Server availability group inside a Cloud's IaaS platform. Otherwise, work with the C-level, reduce your expectations. Maybe it's not quite as dire as they want. And sometimes when they see the price tag associated with true high availability, we're talking just seconds for failovers, well, a lot of times, yeah, they may actually reduce their expectations a little bit. Number 5, what are your security requirements? And this is one of those things where you really need to work with the business on this. What sort of data do you have? I mean, we're in the data space. So there's healthcare data, financial data, all kinds of stuff. And it really matters, depending on the industry you're in, what sort of regulatory compliance requirements that you may be under. Could be PCI, HIPAA, SOX, GDPR. There is a lot of that kind of stuff that's out there depending on what vertical you're in. Who needs access to a given bit of data? That is a really hard thing to determine. Now, I have said it before, your database security practices in on-prem environments leave a lot to be desired. And I'm just making a blanket statement there. And you know it's true. The bigger thing about the cloud is you can't just start unlocking things without any rhyme or reason behind it. Can you read the funny manual? If you can't, this is why when you look at all of the Amazon buckets that are wide open that have tons of important information just sitting out there waiting for somebody to stumble on it, if you read the manual, they can tell you not to do this stuff. You have to follow it. You have to be smart and think about what needs access to what. And a lot of times it's wide open on-prem, and that's not very fun. Just don't unlock these cloud services beyond your needs. You have all the granularity in the world to lock this thing down. Yes, it's more painful. Yes, it takes more time, but do it. If you do this, your security is going to be exponentially better than what you've got right now. The perspective and steps behind this is really tough. When you're on-prem, most things are exposed. When you're in the cloud, they are so locked down by default that you can't even get to it until you poke holes in the firewalls. So at this point in time, this is going to be the tough part. You have to determine and document what needs access to what system. So if you've got 5 application servers with 5 databases on one SQL Server instance, each one of those needs a way in. You've got management operations, monitoring tools. What needs access to what? What app needs what access to what database? All the way down to zones, DR facilities. You have to figure all this stuff out ahead of time. If you do this all the way down to the ports, if you can do this properly, you can lock this thing down so tight that it's going to be really hard to stumble onto the different components there. A lot of organizations that we work with, you try to do a server migration, and 2 days after the migration, you're finding that, hey, this person had an Excel linked to a SQL server. It broke. What talks to what? You got to map all this stuff out so you know and you don't have nearly as big of a disruption after you do that migration. Question 6, and I could spend the rest of the month on this one. How much performance do your SQL servers need? And I'm not saying what the vendors are telling you. I'm not saying what the diehard DBAs think they need. I want you to be objective. What are you consuming today? Do you have a good baseline? What does a normal day at this date and time look like? What happens if you're in the retail business between the holidays? What happens? What does this machine look like? There are third-party utilities out there that do a really good job with this. I'm not going to put them in here because I don't want to market for anybody. I want to be impartial and unbiased. If you're curious, message me. I'll tell you what we think. But again, it may not be the right one for your environment. Go test and explore. See if any of the ones out there are right for you. If you don't have the budget for any of these really fancy third-party utilities, you've actually got something. If you're running SQL Server on Windows today, and you can run it on Linux if you choose, you can use Windows Perfmon. It is built into Windows. It's been there for forever. It just works. No exaggeration. It's just going to be there. We have a document out at our website. And again, no contact info, strings attached. It's literally hit the link here, type it in, and there's just a PDF for you. It shows you how we like to set up Windows Perfmon on literally Windows Server 2008 R2 and above. And we can now start to collect this information. And that's really, really powerful because having an ongoing trace of what is actually going on every single day is going to give you the information that you need to generate a really solid baseline. If you don't have this, how do you know what you're consuming around the clock? How do you know what resources you need in the cloud? How do you know if there's a bottleneck anywhere in there? Everybody on the internet tells you to go collect Perfmon. Nobody tells you what to do with it. Well, I'm going to fix that. Go out to github.com/Heraflux and look for a utility that we released a while back called BLG to SQL. It's a PowerShell script that you can point to the location that all these Perfmon output files are at, and you can load it into a relational SQL Server database. This now puts the raw data in your hands so that you can use any utility you like Power BI, T-SQL, Excel, well, you name it, you can use it. And now you can get to the raw data and generate your own baseline. And that goes down to really what I call right sizing. Right sizing gives me the ability to understand my resource consumption compared to the resources that have been allocated to it. And if I've allocated way too much, I'm going to dial it back. And then I can re-baseline and see how the system responds with less resources. In a lot of cases, what you've allocated on-prem is just simply too much. The machine is functionally idle. You're paying for that in the cloud, whether you like it or not. How much of each of these compute resources do you actually need? And I'm talking CPU, memory, network throughput, and storage speed in addition to storage space. Start to collect this information on what you're consuming. Be careful with that granularity. If you say do collection every 15 minutes, well, reports can run, things like that can run a little slow for a minute or two. If your granularity is really, really wide, the law of averages state that you may actually lose some of that information and maybe water down because of an average. But if you're doing every second, the act of doing the collection is going to slow your server down. You don't need that. I would say about every 30 seconds is when I love to see really good granularity in there because it tells you more what's going on without being a performance load on the machine and slowing it down. So things that I'd recommend doing, CPU consumption by core. We may have things like CPU NUMA imbalances. We may have single-threaded processes running around the clock. These sort of things you're not really going to see if you're just looking at a total average on the machine. There's a memory usage for SQL Server, and I'm not talking operating system level. I'm talking get into the instance, and Perfmon can do this. Page life expectancy, memory grants pending, buffer cache hit ratio. There's a lot of different memory pressure warnings in there. You have to understand where to go look at this stuff. But if you collect this, you can start to take all these and put them together and figure out just how much memory is SQL Server using or thrashing or sitting idle. Do we need more? Can we get away with less and be fine with performance? The same thing goes with storage. And I'm not just talking capacity, gigabytes or terabytes. I'm talking demand. So an IOP is an IO per second. It's literally a measure of the demand of a given storage and its ability to deliver as fast as you can ask for it. There's throughput in there, but all throughput is IOPS times the block size of the access. You put all that together, there are IOPS caps in the cloud by virtual disk and at the virtual machine layer. So if you only need 4 CPUs, but you need 20,000 IOPS, you might end up having to have either a storage bottleneck that's present from the day you migrate, or end up buying a virtual machine that's got a bigger scale on it so that you can actually allocate more storage speed. And these are things you got to worry about. Get the measurement of what you're consuming right now. You can see we ran this at one particular customer. There was a 16-core SQL server. They didn't know. 8 cores were just freaking out around the clock. They had no idea this was occurring. It was a really big nightmare. Now we went in and cleaned this up. There was a NUMA misalignment. Soft NUMA was on and doing bad things. Our SQL Server workload had some parallelism settings that were not good. When we were done, note the scale. We've got a decent amount of CPUs still for now, but that caps out at about 35%. That was nowhere near as aggressive as before, and as a result, we were able to downsize the machine, save some money, and make this thing faster in the process. The resource allocation methods that you can use to go deploy this stuff varies a little bit. If you're dealing with IaaS, you're dealing with virtual machines. So you select the series like Azure D series, DS, EM, those sort of things. Some of these can be memory optimized, some are CPU, some are storage optimized. You select the series and then you pick the scale. So you can see here on the screen DS13V2, 8 core, 56 gigs of RAM. You got a good amount of temporary storage. In this case, a little over $4 USD per hour. Not a big deal. You select the scale of the compute and then you attach the managed disks at the scale and the IOPS caps that really matter to you. If you're dealing with database as a service or platform as a service, there is a modern vCore model. So you can say, I need 6 cores, 8 cores, 10 cores, 12 cores. The memory allocation comes along with it. You don't have to worry about it. And then it's just a slider to say, I need this much space. You get out your credit card and life is good. Number 7, how are you migrating your data? This is a big challenge. The migration strategies are nowhere near as simple as a backup and restore most of the time. Now, if you're just doing a virtual machine out there, okay, yeah, that's not that bad. You can do a backup and restore, you can do log shipping, you can detach, copy, attach, you can do mirroring, if you really want to deal with transactional replication, you can do that. Or you can stretch an availability group out there. Or if the database is reasonably sized, you can do a backpack export or import. Or Azure Data Migration Assistant. There are tools out there that can help you with this. The VM gives you the most flexibility out there. Now, if we're looking at a managed instance, most of the time we can do most of these. Now, we can do a backup and restore directly from URL to Azure Blob just to find a credential out there or a SaaS token and call it good. We can do a backpack export and import again, or we can use Azure Data Migration Assistant as well. Now, if I'm doing an Azure SQL database, it's literally just a database. We don't have a good means to actually back up from on-prem, literally restore it in the cloud. So we got to be a little more creative. We can do a backpack export and import. We can use the Azure Data Migration Assistant, or we can use Azure Data Migration Services, which can help basically pump data from on-prem into the cloud and keep it in sync the best that your bandwidth has the ability to do until you're ready to cut over. All of these work well. It's just a little bit different than what we've dealt with on-prem in the past. There are some constraints for getting the data back out. Let's just say you go down the rabbit hole, you want to use an Azure SQL DB, and then 2 weeks right before you're due to go live, somebody said, hey, but we've got this other database and it's got a 3-part name and we can't change the code. It's like, oh, shoot, what are we going to do? So we have to figure out the constraints around the given platforms that we've got. These can be things like, what if I just want to take a production database and refresh a pre-production copy so my developers have a more up-to-date copy? That hurts sometimes. We can't necessarily do a backup of a SQL DB into a regular SQL server. Sometimes these things don't work. You actually cannot back up from a managed instance to a regular SQL server as well. You can back up and restore to another managed instance. Sometimes we have to deal with a data extraction process like a backpack or SSIS, and that becomes our method to extract that data. And it's not the most fun, to be honest, but these are the constraints and these are the limitations that we have to work with. If the other pieces work on there, there are options for this. It just might not be quite as pretty as what we're used to. Number 8, and this is one I hate to be the bearer of bad news, but I might have some good news for you here. Have you validated your SQL Server licensing needs? Well, one, How are you currently licensed? And I hope you are currently licensed, but how are you currently licensed? And specifically, with the agreement that you're under now, does your licensing transfer to the cloud on some of the cloud benefits, like the Azure Hybrid benefit? You can actually migrate those licenses as part of server migrations when you go from on-prem into Azure. And it's actually really handy. You do need to be under software assurance. You can also transfer these between on-prem virtual machines and databases as a service out there. There are also DR specific licensing clauses, especially under SQL Server 2019. You can actually run a copy for DR purposes in the cloud, and all you got to do is pay for a compute on there. It's a lot of good stuff that comes with it. Run the numbers ahead of your migration. Make sure to right size your destination. I cannot stress this enough. Allocate the compute that you need, not necessarily what you've been allocated now, and make sure to research to make sure your existing licensing falls under the Azure Hybrid benefit, and then go apply that to the cloud. You can do this. It really does work. But again, it does require software assurance. So if you're doing net new purchases now with the intent to go to the cloud soon, make sure you buy SA. The DR specific licensing clauses out there, again, make sure you're aware of them. It can actually save you a lot of money. We do have a couple of organizations that we help save some cash out there with those. Now, the next one is one I, again, could spend an hour or two on. Have you calculated the monthly cost of your cloud services? And this goes back to running the numbers. What are you doing? Now, this is one of the biggest myths in the cloud. The phrase that people love to use is pay for what you use. They make the analogy the cloud is similar to the power bill for your home. You literally pay for what you consume. Well, cloud is partly that model. Things like Azure Blob Storage, networking throughput, load balancer, DNS lookups, those sort of things. Yeah, it's pay for what you consume. But specifically in the data space, it is partially pay by what you allocate. And this is where things get into trouble. Database IaaS, platform as a service, sometimes database as a service, managed disk. If you go provision a 32 core Azure SQL managed instance and then forget about it, you are going to get paid for that whether you use it or not. So it is literally pay by what you allocate and not necessarily pay for what you use. So we got to be smart about this. Example here, business critical Azure SQL managed instance. I'm going to deploy this as Gen 5, 8 virtual cores, 256 gigs of storage. Right there, estimated cost 2,241 USD at the time I took the screenshot. Be careful with this. If you don't need all 8 cores, or if you turn it on and forget about it, you're still paying that. That adds up really quick. The factors for the sizing really go a long way here. Take a really good look at the perfmon data that I told you about a little bit ago. Understand, what's my peak consumption rate? Is that peak consumption during business hours? What's the peak consumption during business hours? If my highest time of CPU consumption is in the middle of the night when I'm running an integrity check or an index maintenance operation, does that matter when I go to the public cloud and try to downsize this thing? Well, if it's time sensitive, sure. If it runs in 30 minutes and I've got 8 hours to run it in, yeah, you could probably get away with skimping on that a little bit. And then how much memory do you need? And remember, memory in SQL Server acts as a working set data cache, which includes a read cache for storage. So if I have more RAM, do I need as much storage speed? Maybe, maybe not, especially if you have a high rate of data change. It's up to your workload. But factor in how much storage speed that you need, which may depend on which criticality tier. And then storage space comes along with it. How fast is your data growing? How much data are you adding every month? Are there any new initiatives coming down the pipe that we need to worry about? And then networking bandwidth. Now that's a minor charge in there, but occasionally people move a ton of data around, and that can start to stack up. And then figure out your disaster recovery needs. So given my SLAs for DR, what are my needs there? Is it literally just cold storage on Azure Blob? Are these hot VMs that we need up and running all the time? How much do I want to test them? How warm do I want them to be? The Azure Calculator can go a long way to helping you. So if you understand the service and understand the scale, I can now start to get the prices of this stuff. So this was configuring an Azure SQL Server virtual machine. In this case, Just an operating system tier is standard. So it's a DS13V2, 8 cores, 56 gigs of RAM. On average, it's 730 hours a month. We're going to do pay as you go on this quote. Operating system, I just want to let them deal with it, so I'm going to pay with it. In this case, the compute side of it is 770 USD a month. And then I'm going to add a couple terabytes of SSDs, add a little bit more for your managed disks. And in this case, we're looking at 944 USD a month. Okay, it is what it is. Now let's add a SQL Server license on there. If I want to go a SQL Server standard at this scale, that takes my monthly cost from 944 up to 1528. Let's say I need to go to SQL Server Enterprise. Let's functionally double. Weigh the math. Look at your environment. Do the math not just by month, but on maybe a 3 or 5 year cost of ownership and just see how it stacks up. Now, if you're looking for a way to try to trim some of the cost, let's just say we've got a dev database that's up and running, but nobody's accessing it in the middle of the night, nobody's touching it on weekends. Azure SQL DB now has an option for serverless, which I absolutely love. So let's say I need an Azure SQL database, 8 cores, minimum of 2 cores. And if it's not been accessed for a certain period of time, it'll actually decrease the scale of the database and charge you less. You still got to deal with the storage behind it, but the compute cost can come down. And if you set, dev or lightly used machines that are production based, where nobody's touching it in the middle of the night, maybe this can help you save some money. It's pretty darn handy. So when you're deploying these things, look for the serverless option out there. If you're deploying these things, single database, compute tier serverless, you set a maximum number of cores and a minimum number of cores with an estimation on how much you're actually moving it back and forth. And you can see an average build vCores 1.62, and we can see that the price tag is going to come down. It shuts down after a certain period of time. I love this. We use this for a handful of the things that we do personally for our operations, and it saved us a pretty good amount of money because, we're not up in the middle of the night sometimes. The biggest thing to realize, this thing is built for the compute at the vCores that it's using at the time, which can be higher or lower, but you're always going to be built for the storage. So, again, be smart in how much you're putting on disk. Save some money. Scale this thing down when you're actively using it. Now, number 10, and this is one of the hardest things to project. What are your future needs in these platforms? This is really tough. What are you doing to plan for tomorrow's needs, growth, business changes? What are you doing today to deal with this? So, an easy one. How much space consumption for your databases are you adding every month, every quarter, every year? What business changes are you aware of that are coming? We've got a couple businesses in the manufacturing space. They are on a buying frenzy. They're buying a lot of little manufacturing shops that are really good and really niche at what they do. So they're adding tons of users and tons of space with past data, current offerings. They're growing fairly quickly. If you see any of these coming, what can you do to get in front of that? What upcoming projects or initiatives? Maybe you got a data warehousing environment you got your business wants to build. Maybe you got reporting. Maybe you need copies of data, more copies for upcoming development projects. Think about what's coming. Work with everybody involved to figure out, do they know something that you don't? And then review your application architecture. You know what skeletons are in the closet. You know where the scalability and limiting factors in your own environment actually are. Go take a look at that. What are some of those limitations? What are the flaws? What can you do to leverage some of these cloud features to either fix them or change them or improve or actually retool them to take advantage of some of the new offerings that are coming out in the cloud? And then, do you have vendor lock-in? Do you have an ERP vendor, for example, that is requiring a virtual machine because they do really silly things? Well, understand this. Understand if any of these things are coming. Because as you can tell, walking back from one path from a data platform and going to a different one is not always as easy as it seems. So put it all together. The cloud is one of the greatest tools that you can add to your personal and professional toolbox, but it is not the only tool. And I'm going to say that a bazillion times. Migrate to the cloud for real, legitimate reasons. Choose your path carefully and make sure that you can optimize and figure out the model to really monetize the benefits in the cloud. Understand your cost model. It is an operational expense. Understand the right sizing. Understand if there's a way to transfer existing licensing or save costs by applying all this stuff. It really does matter. Plan for the future with the best that you can do. If there are any questions at all, please do not hesitate to contact me out here. I'd love to answer anything that you've got. Thank you for being part of the Cloud Lunch and Learn Marathon. I really appreciate it. You can check out all the recordings on YouTube there and check out the Twitter channel below. And I want to say thank you to all the sponsors for this awesome event. So thank you all for listening. If you have any questions, let me know, and you all have a great day. Thank you.